Day 737 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we got question number 2770, maximum number of jumps to reach the last index. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero index array nums of n integers and an integer target. You are initially positioned at index 0. In one step, you can jump from index I to any index j such that 0 is less than or equal to I, and I is less than j, and j is less than n. Negative target must be less than or equal to nums of j minus nums of I must be less than or equal to target. Return the maximum number of jumps you can make to reach the index n minus 1. If there is no way to reach index n minus 1, return negative 1. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, first, I just want to point out what these requirements are. So first, index I, this has to be less than index j, right? That's the first requirement. And the second requirement is nums of j minus nums of I has to be in between target and negative target. Boom. So that's what this line means right here. So let's go ahead and take a look at these examples to see what they mean by that. So in example 1, we have our input nums equals an array of integers 1, 3, 6, 4, 1, 2. Target equals 2. Our output is 3. The explanation says to go from index 0 to index n minus 1 with the maximum number of jumps, you can perform the following jumping sequence. First, we're going to jump from index 0 to index 1. So let's make sure this fits our requirements. So I copy and paste this over here as we go through it. Boom. So let's make sure from index 0 to index 1 fits these requirements, right? So we already know I would be 0, j would be 1. So we already know 0 is less than 1, so it fits this requirement right here. So now let's check this requirement. Target is 2. That means 1, or the value of index 1, minus the value of index 0 needs to be in between 2 and negative 2. So let's see what that is. The value of index 1 is 3. The value of index 0 is 1. 3 minus 1 is 2. And that works because it could be less than or equal to target. In this case, it's equal to target. So boom, that fits the first requirement. I guess we didn't need to do this over here. Boom. Then we jump from index 1 to index 3. So that would be this 3 to 1, 2, 3 to this 4, right? That's our next jump. So after that jump, that would be, so we already know 3 is less than 4, so it fits this requirement. And then 4 minus 3 is equal to 1, which is in between negative 2 and 2, so it fits this requirement. So boom, that's the second jump. Boom, then the jump from index 3 to 5, so we jump from here to here. Boom, so we already know 3 is less than 5, right? Boom, so fits this requirement. So as you can see, it has to jump to the right. It cannot jump backwards. The jump has to be to the right. Boom. Then, so let's see what the value of that was. Index 3 was 0, 1, 2, 3 to 2, so 4 and 2. So 2 minus 4 is going to be negative 2, but once again, that is equal to our negative target, so this jump works as well. And it can be proven that there is no other jumping sequence that goes from 0 to n minus 1 with more than 3 jumps. Hence, the answer is 3. Because remember, we want the maximum number of jumps. There may be a way to get less number of jumps, but there's no way to get more than 3 jumps. Boom. So just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our input nums equals an array of integers 1, 3, 6, 4, 1, 2. This time target equals 3, the output is 5. So to go from index 0 to index n minus 1 with the maximum number of jumps, you can perform the following jumping sequence. So first we're going to go from 0 to 1. That goes to the right. So we already know that fits the first requirement. And then 3 minus 1 would be 2. That's less than target, so fits the second requirement. Boom. Then we're going to jump from index 1 to 2. So we're going to go from here to here, goes to the right, so we know it fits the first requirement. 6 minus 3 is 3, so fits the second requirement as well. Boom. Then we're going to go from 2 to 3. So boom, we're still moving to the right, still fits the first requirement. Then we do 4 minus 6 is -2. That's still in between 3 and -3. So that fits the second requirement as well. Boom, then we're going to go from 3 to 4. So 3 to 4 would be 4 to 1. Once again, it goes to the right. Then 1 minus 4 is -3. That is equal to the negative target. So we know this one works. Boom. Then we go from 4 to 5. We know it fits the first requirement. Then once again, 2 minus 1 is 1. So boom, fits the second requirement because 1 is in between -3 and 3. So boom, then it can be proven that there is no other jumping sequence that goes from 0 to n minus 1 with more than 5 jumps. Hence, the answer is 5. Now let's take a look at example 3, last but certainly not least. So in example 3, our input nums equals an array of integers 1, 3, 6, 4, 1, 2. Target equals 0. The output is -1. It says it can be proven that there is no jumping sequence that goes from 0 to n minus 1. Hence, the answer is 1. So since it's impossible to make it from here to here, while following these requirements, it says right here, if there is no such way to reach index n minus 1, return -1. And that is what happened here in example 3. So boom, now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we want to do is we're going to get the total number of elements. So we're going to say let n equal nums.count. Boom. Now we're going to use some dynamic programming. So we need to create our dynamic programming array, which is going to be the maximum number of jumps needed to reach index I. So we're going to declare a variable called dp and set that equal to an array. Open up the parentheses. We're going to say repeating (-1, comma, count, (n). Boom. Then we're going to come underneath that and we're going to reserve memory in advance for slight performance optimization by saying dp.reserve capacity, open up the parentheses, and we're going to pass in n. Boom. Then we're going to come underneath this and we're going to starting from index is going to require 0 jumps to reach index 0. So we're going to start at index 0 by saying dp square bracket 0. We're just going to set that equal to 0. Boom, and we're going to try every starting position. So we're going to say for I and 0 ... less than n minus 1. We're going to open up the brackets and we're going to try jumping from index I to every later index j. So we're going to say for j and I plus 1 ... up to n, we're going to open up the brackets. And then, or excuse me, we're not going to open up the brackets just yet because we're going to only continue if index I is reachable and the jump condition is valid. So we're going to say where dp square bracket I does not equal -1 and 2 and signs abs, so the absolute value of nums square bracket j minus nums square bracket I is less than or equal to target. Then we're going to come over here and we're going to open up the brackets and we're going to update the best jump count for index j. So we're either going to keep the current best or use the path through I. So we're going to say dp square bracket j, come outside of that, equals max open up the parentheses, dp square bracket j comma dp square bracket I, come outside of that square bracket and say +1. Boom. Hold on, y'all, because this square bracket was supposed to close right here. Oh, sorry, y'all. Boom. So it should look like that. Then we need to return the maximum jumps needed to reach the last index, and if it's unreachable, then the value will remain -1. So we'll just come down here and we'll say return dp square bracket n -1. Boom, y'all. That should be all that she wrote. Let's give it a run. Okay, let's see. Cannot find num. So that should be nums with an S. Let's run it again, see if that made it work. Okay, let's see. Let me see, one moment, y'all. Oh, y'all, my bad. I got the parentheses are supposed to close right here. I had it in the wrong spot. So now let's give it a run and see if that did the trick. Let's see, it's accepted. So let's go ahead and submit it and make sure it's still accepted after we submit it. And look at that, y'all. 9 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.